So welcome everybody to this session on Spring Data repositories and best practices around it. My name is Oliver Gierke. I'm the project lead of the Spring Data project, organizing the development of the individual modules, and also member of the JPA 2.1 expert group. So in case you have questions about future of JPA or new features in 2.1, feel free to ask them. With me is Thomas Darimont, Spring Data engineer, mostly responsible for JPA, MongoDB, and Redis modules. He will be answering your questions while I'm speaking, so that you can just drop them and get them answered. As Peter mentioned, we will save some of the questions for answering them live at the end of the webinar. So what is it that we're going to do today? I have prepared a repository for you, a GitHub repository that actually has a lot of code in it, and it looks something like this. So if you check it out, and be sure to check out the webinar 2014 branch, because we change that quite frequently, but we will keep the webinar branch stable so that you exactly see find the code that you've seen in the demo here. We have individual commits for every step that we're going to walk through. And what I want to do with you is just go through a list of requirements and effectively build up a data access layer for an application step by step. So starting very simple, getting more complex, and while I'm doing that, introduce you to some best practices that we've seen in customer applications or in Spring Data usage in the wild. All right, so the first, or actually the step 0 here, is that we need some initial project setup. And if you want to work with Spring Data or persist data, you need to actually set up a project first. And all we know upfront is that we want to use Spring Data JPA, and it should be a Maven project. At least that's what I've chosen here in the first place. There's no problem to use that stuff with Gradle, of course, but because most of you people are probably familiar with Maven, I chose that. You see, we don't have too many dependencies listed here. We use a parent project from we have Spring Boot and a few dependencies. Spring Boot is a relatively young project of the Spring ecosystem, and it effectively tackles the issue of setting up a project and having to provide a lot of default configuration in the first place. So what this does here is with the parent project is we get a set of predefined dependency version declared, so that you see that down here we don't have to state any version numbers for the most regularly used dependencies. And through the dependency blocks in here, we pull in certain sets of dependencies. So in this case, this boot starter data-jpa dependency will automatically pull in the Spring Data JPA project. It will choose, in this case, Hibernate as persistence provider, and it will make sure you have all the individual dependencies chosen in the right version. This especially gets important if you start to combine Spring Data with Spring Security, with Spring Integration, and what have you. Spring Boot will make sure that you use them in the right versions, which effectively means in compatible versions. The Spring Boot starter test dependency here results in basic test dependencies pulled in, like Mockito and JUnit and what have you. Right, that's effectively it. So just the project setup. I've also added a few JPA domain classes here, a customer with an embeddable email address here, and related address instances. Very simple to just not make it more complicated than it needs to be. Base class for the entities to carry the ID property. That's all we have for now. All right. So I recommend you to have a look at Spring Boot and easily configure your projects, get them set up, because what Spring Boot also does is it will default your application configuration based on the class path, and that's what we're going to see in a second. All right, let me go there. Right, so I checked that out, and we should see the IDE updated. All right. Okay. So what you see here, the first step, what you see here is we've added an application configuration class. For those of you only familiar with XML configuration, we're using Java config here, and that means we have a class that configures the application, not an XML file. The class carries some enable auto configuration annotation that is coming from Spring Boot, and I'll go into that in a second, because what we have here is a basic test case that just bootstraps an annotation config application context with that configuration class and an abstract integration test that we will use for our integration test that we add later on. You see that we're using the @Spring application configuration annotation here, which is a variant of the one that you're probably used to, the context configuration annotation. It will effectively run Spring Boot for you, and that causes the application defaulting to take place, right? So if we're going to add additional code in the upcoming steps, that makes sure we get all the infrastructure set up. In this case, for example, Boot inspects the class path, sees we have Spring data-jpa on the class path, we have Hibernate on the class path, so it will configure an entity manager FactoryBean by default using Hibernate and setting up Spring Data repositories without us having to do that, because that's just boilerplate code that we would take from example to example. So there's nothing really in here. I can just run the database population integration test here. It's called database population integration test because we just need a test method to actually run this thing. And what it also does is there should be a source test resources, a SQL file, a data SQL file that Boot will automatically pick up to create to have some sample data in here. So it's inspecting the class paths for some well-known locations, and we'll just use them. All right, that's actually it for that, right? All right, that's what we've just seen effectively, right? So we're using Java config, and we have some sample data here. So you've seen that that's been quite easy. We didn't have to configure anything specifically. There's no XML files involved. There's no persistence XML file involved because Boot automatically activates the component scanning for JPA entities, and that's effectively it. So zero effort bootstrapping of application context and infrastructure default. All right, so let's get started quickly with the basic Spring Data stuff. So we want to start with Spring Data repositories. We want to be able to save customers, look them up by their ID and by their email addresses. All right, so we check out the next step. All right, so what do we have here? We have the repository interface here. For those of you not already familiar with Spring Data a little, the entire idea is centered around you just declaring repository interfaces and Spring Data providing the implementation by some means or others. So we declare a customer repository here. We let that extend a base repository, which allows the Spring Data infrastructure to find this repository. And then we declare two CRUD methods here, find one and save method, yeah, as well as a query method. And we will have a look at those in a second, right? So we create a dedicated integration test for the repository. We just wire an instance of the repository into the test. It's still, I mean, it extends abstract integration test so that it bootstraps the application context, defaults the entity manager factory, finds the repository, and then effectively provides us with an instance of it. So we can use that. We can invoke the find one method, the save method, and save existing customers, and we find customers by their email addresses. So I run this real quick for you. In the meantime, just a few words on the methods that we declared. Two of those methods, the save and the find one method, may seem very, very independent of your domain. I mean, they're typed to your domain types, but that's what generics are for, right? They're actually implementable by a custom class that we have here, like it's called simple JPA repository, and Spring will actually use that, or Spring Data will actually use that class and create an instance of it to actually execute the call to the find one method, right? So that's where your call will actually end up. For the find by email address, it's a bit more complicated in terms of, okay, we need some more logic here, because we effectively need to return this into a query execution. And if you don't do anything else but declaring the method, we derive the query from the method name. So we find this is a repository for customer, or it's the return type here. So we look up, we drop the prefix, we look up an email address property on the customer, which it apparently has, email address, and so we're done with the query derivation, right? So for very simple queries, this is just fine. You get code completion on, let's say we do customer and say find by. You get code completion from Spring IDE for the properties of the customer, and you also get keyword completion. So all the keywords that make sense with a string property in this case will be listed here. Let's say we take is ending with, and say first part something, right? That just works. If you happen to create a typo in here, the IDE will warn you on that and will show you that it says, if you can't read it, it says no property first, none found for type customer. Right. This is actually a validation code that we run when we bootstrap the application code, the application context. So you will never end up with an application running invalid derived queries, because that just cannot happen. It will throw an exception in application context startup time. But you also get this feedback in the IDE already, so you don't need to rely on starting that stuff. Okay, that's effectively it. So you see, for the very simple use cases, you don't even have to write any implementation code. We derive the queries from the method names by default. Support quite a wide variety of keywords. You can of course concatenate them with and or, and yeah, that's actually it. The very basic stuff. Okay, so as a next step, let's assume we want to add more CRUD methods to the customer repository. To do so, let me check out the commit. To do so, we could just go ahead and add further methods to the customer repository, right? But assume we have more than one repository in our application. We certainly don't want to declare the save method on all of our repositories, but have them at declared at a single place. And that is where CrudRepository comes into place. Also, in a Spring Data base repository, so to speak, it contains quite a few CRUD methods, and you can just pull them into your interface by extending that method, that interface here. Right? So we dropped our manual declarations and extended CrudRepository instead, so that we can effectively call the find all method and the delete method as well, right? So that's a nice and convenient way to just quickly pull in additional repository methods there. Okay. A slight downside of that is that you expose, or that the set of methods that you expose is defined by Spring Data. So you all of a sudden expose delete methods, you expose save methods, stuff that you might not want to do, and we will have a look at how you can achieve that, how you can prevent that from happening at a later stage. But that's just a side effect of choosing CrudRepository here. All right. So especially with JPA, you usually don't want to read too much data. With too much, I mean like hundreds of thousands of customers in at once, because they consume quite a lot of memory, especially because of JPA being a list-based data access API. So if you have, let's say, 10,000 customers as a result, these 10,000 customer objects need to be instantiated. They have to be put on a list, and then they are given to you. To avoid too much data to be, or too much memory to be consumed, people usually prefer to page through the data. So we want to access the customers in a page-by-page way, so that we can consume it in chunk by chunk, actually. We can achieve that by moving to yet another base repository, which is the customer repository. We moved away from CrudRepository now and went to paging and sorting repository, because that adds two new methods that come in handy in that use case. The more important one of it is the find all taking a pageable. A pageable is effectively the definition of which page you want to access, and an implementation of that can be seen in the customer repository integration test here. We use the page request. It just says, in this case, I want the second page by a page size of 1. Right? So in this case, we had 3 customers. We effectively get the one in the middle, and we can do on the page object that we got returned here, we can do obtain additional meta information about the page. Is it the first page? Is it the last page? How many pages are there in total? All the stuff that you would have to code yourself if you just wrote something like this on your own. A good hint here is probably that, you see, we don't necessarily check for the actual customer being returned. That is because we don't define any sorting criteria here, which you of course can if you just use the constructor here that takes a sort object or a direction and an array of string properties. That's the way you had to define it have to define it with the current version. In the upcoming Spring Data COD version, there's a new sorting abstraction in there that you can use the criteria API meta model classes to define sorting criteria in a type-safe way. And we also have support for a library called Querydsl, but I go into that in a second. Right. Okay. Where have we been? There we go. All right. So you would usually extend paging and sorting repository if you need to page through the entire set of repository of entities. We expose both the CRUD methods and the paging ones, and we even extend our API, right, that we exposed so far. Okay. the CRUD methods that we expose, they get some defaults applied in terms of the transaction configuration, and also you've seen a typical the CRUD repository returning iterable in the sample that I showed you. And we can go back to that in a second. Where is it? The repository. There we go. We've seen a method called find all. It returns an iterable on CRUD repository. That's kind of weird if you're used to work with JPA, but that stems from the fact that the repository abstraction is available for not only JPA but also NoSQL stores, and as they are dealing with huge data sets usually, they usually prefer an iterating access to data, so that you don't have to create all of the object instances at once, but can create them while you're iterating over the result set. That made us actually choose iterable as a return type for find all, right, to allow those implementations to do exactly that. However, if you want to work with JPA, you might prefer the list-based access. And I don't know if you've seen that before, but when I showed you simple JPA repository, the find all method here, it actually returns a list, right? Because Java 5, or as of Java 5, it was allowed to return a more concrete type than the interface actually declared. And we can use that in CRUD repository not in CRUD repository, in customer repository, to simply redeclare the find all method to return a list. And that will actually allow us to call things like size and what have you on the result. The other aspect I already mentioned is that our save methods, or the manipulating methods in general, get some transaction configuration applied by default. And that default is also available, or can be seen at the simple JPA repository. So we just say add transactional, because JPA requires a transaction to be in progress. However, if you want to customize the transaction configuration for that method, you can't simply change the simple JPA repository. So what you do is you redeclare the save method, or the method you want to customize, and annotate it with add transactional. In this case, we set the timeout to 10, and that will actually cause that configuration to be preferred over the default configuration. We will see other examples of method reconfiguration, or actually the annotation-based configuration of the method execution in a second. All right. It's probably been a bit special here, but that's something that comes in very useful, and if you're running into situations where you need to customize that stuff. Okay. I showed you how to redeclare the methods. You can change the return types, of course, in some limitations there. And we generally support annotation configuration on the query methods, or on the CRUD methods. So we have annotations to define the log modes. You can add query hints to the query execution. All of that stuff that you need if you want to tweak the execution for your persistence provider. All right. So a slight downside that I mentioned briefly when we moved to CRUD repository before is that we now all of a sudden expose finding methods and saving and deleting methods at once. However, let's assume you have the requirement to expose the products in a read-only way, maybe even extend the requirement to not only the products repository to behave in a read-only fashion, but also other ones. So what we can do to actually achieve that is we can craft our own read-only repository base interface. So far, we have only been using, let me close those real quick. We have only been using Spring Data provided base interfaces. And let me check, refresh to make sure we see the latest and greatest. Yeah, so we've only been using Spring Data provided base interfaces. And the ones that we provide out of the box have come out of a debate on which granularity we should expose those repository interfaces, balancing between the number of available repositories and the flexibility that you have, right? So what we do here now is just we create for our application, we create a special read-only repository interface that in turn extends our repository marker interface, and it contains all the reading methods that CrudRepository actually has. So it's effectively a copy of the declaration of the methods, and we can now use it as the base repository for product repository. Because it also extends repository, we will still recognize product repository to be a Spring Data repo here. So you see from the outline view here that we have all the find methods, we have even the paging ones in there, and we have the single find by description containing method. Right. That's effectively it. The intermediate repository interface we introduce here also nicely serves the fact that we can now have an application-specific base repository. So what you also see here is that we fixed the ID type to long, so that all of our entities effectively are forced to be of ID type long to be consistent. So we generally see a lot of customers that create their own base repository and also limit the dependency to the Spring Data interfaces to exactly that single repository, or even multiple ones, if you need a save-only repository or deleting repository or what have you. All right. So we recommend to craft custom base interfaces. There are also store-specific interfaces like JPA repository, which you probably see in a lot of tutorials out there, because people see, okay, they use Spring Data JPA, so they want to use JPA repository. We actually don't recommend to do that because it contains a few JPA-specific methods. That's why it's the JPA repository-based interface. But if you don't need them, I recommend not to expose them, as it effectively binds the client to the persistence technology to some degree, right? But paging and sorting repository should be the default, or CRUD repository even. And if you're not satisfied with those, craft your own ones. That's just fine. All right. So we've seen the query derivation mechanism right now already, but you might run into situations where using the query derivation mechanism is not suitable anymore. It doesn't really meet your querying needs. And what plays into this is that you usually you get quite far with the query derivation mechanism, but as soon as you getting into real-world queries that involve joins and what have you, you don't really want to squeeze all of that into a method name, because that would just make the client code awkwardly to read. And yeah, I mean, these are the two drivers. You don't want to overstretch the method name. I mean, find by description containing is just fine probably, but like something involving joins is probably not that readable anymore. And you might even run into a situation where it just doesn't, you can't really derive the query from the method name anymore. In this case, we have a map lookup. Where is it? The product has an attributes map in here, so that we can store arbitrary attributes alongside them. And yeah, we define a manual query here. This is JPQL, of course, because we're using Spring Data JPA. We have the support for the store-specific queries in other modules, of course, as well. In Mongo, you would use JSON queries, and in Neo4j, it would be Cypher queries or what have you. For JPA, we also support the execution of named queries. So as soon as you have a query for, let me take the one above here, that's called person.find by description. Yeah, there we go. It's containing. And if a named query is present that follows that naming convention, it will be used automatically, right? So you can externalize those if you need to. All right. That's actually it. Okay. There's also a mechanism, a Spring Data specific named query mechanism, but that's only used if you want to, or if you need to switch between the repositories, like for Mongo and JPA, very frequently, and you want to externalize the queries and not have them in your repository interface. Right. That's effectively it. All right. So the query derivation mechanism and the manually the declarative queries get you quite far in terms of being able to just execute arbitrary queries. However, if you get into the situation that you want to create more flexible queries on the fly, the query methods are not really an option, right? So assume this requirement here, we want to search by first name, by last name, by email address, or by first name and email address, by email address and last name, what have you. If you were using or trying to achieve that with query methods, you would run into an explosion of the number of query methods. And something we actually recommend to use in that case is a tiny project called Querydsl. Querydsl is, let me check that out, is based on an APT, an annotation processor, and will create meta model classes for your domain classes. It doesn't necessarily need them, so it can also work without those generated classes. But the benefit you get from that is you can refer to individual entity properties in a type-safe way. So that QCustomer class that was generated here has properties, first name, addresses, and what have you. Yeah, we will have a look at how that actually helps in a second. But that's effectively it. It's until now it's very similar to the meta model API for the criteria API, but it actually has the much nicer API, if you ask me. Besides the fact that Querydsl does not only work with JPA, but it also works for MongoDB, for Lucene, for other stores. Yeah, that's why we actually chose it in the first place, to integrate with it. So you say you get access to an instance of that generated class, and then you say customer.first name. You see you get code completion, and you also get the keywords like ends with, and I go with foo, and can assign that to a Boolean expression here, right? So no criteria builder, no root, no criteria query, and all of that stuff is just gone. You cleanly can define your predicates. It reads nicely. It of course breaks correctly if you refactor stuff, but yeah, so it can just type in define queries or predicates in a type-safe way. You can of course also combine them into new predicates. So you see that OR concatenator here, and we pipe the resulting predicate into a find all method here. Where is this find all method coming from? Yeah, it's from a type called Querydsl predicate executor, which has find methods that take the Querydsl predicates here. And how do we actually get this interface into our repository declaration? Yeah, we do so by simply adding it to the list of repositories that we extend. So you see here the customer repository was changed into being a paging and sorting repository. We've seen that, right? But we can just add the Querydsl predicate executor here, and this already gets into some interesting area that we round things off later on. The repository interface becomes some kind of a central entry point for data access functionality, and consists of different aspects of functionality, right? So with paging and sorting repository, we pull in CRUD methods and paging methods. With the Querydsl predicate executor, we pull in the ability to execute the predicates, and right in this repository, we define the query methods. So it's effectively like a toolkit for you to choose the right tool to meet your data access needs. Right? So if a query method is the simplest thing to do, just add it. If you need more flexibility, just go with the predicate executor. All right, that's effectively it for Querydsl. Very easy, very cool project, I think. And yeah, it will definitely change the way you write queries. So we will have a bit of sample code showing you how to write queries with it explicitly, but let's go on for now. All right, the final step actually is step 9, custom implementations for repositories. So you already, at this point, you already have quite a variety of tools at hand to implement your data access needs. But let's assume you get some requirement that doesn't really fit any of them, right? So you want to delete something here, you want to store, like manipulate something using a modifying query or what have you, or even for performance purposes, rather use JDBC instead of JPA to, let's say, issue a bulk delete or what have you. To do that, you can actually pipe a few bits of custom implementation code into your repository. And you do that by leveraging the mechanism I actually just showed you. Because the important part, again, let me close them real quick. The important part, again, refresh. Oh no, it already did. Okay. The important bit again here is that you can you can assemble your repository from different interfaces. And for the product repository, we go with our read-only repository that you've seen before, and we add here a product repository custom, as I call it, which effectively represents all the functionality that we want to implement ourselves, right? That's why we've externalized it, because it's very easy to just write an implementation code for those methods declared in here, right? So we do so by using product repository info, and within that class, you're pretty much free to choose whatever persistent technology you like. If it's rather JDBC because of performance reasons, inject the data source here, inject the JDBC template, off you go. In this case, we're using a Querydsl specific base class that helps us to actually manually implement a query with the help of Querydsl. You see again down here, very, very concise way of defining the queries. The delete method is actually a template method that we call it from Querydsl support. So it will effectively set up a delete query for the product that we hand in here. But yeah, you're virtually free to do anything you like in here. You can just call whatever code else. That's just fine. Okay. We've pulled in the custom repository interface into the product repository, which effectively makes the method, the remove products more expensive than method into the interface so that a client can actually call it, as you can see down here. But that probably raises the question, how does that all find together, right? And that's actually the last part and the most implementation specific part of the presentation here. Just to make you understand how the repository proxies work. On application context Bootstrap, the Spring Data infrastructure is enabled, and we detect the repository mechanism, the repository interfaces, just by component scanning, as you would scan for add service, annotated class, or what have you. We then go ahead and inspect the class for query methods that we find, and we also try to find a class that is named just like the repository. Let me just go back to the code. That's probably better explained here. So we find product repository, and by default, we try to extend that name with info, product repository info, and see if we can find a class for that. And if we do so, we created an instance of it, declare a bean definition for it, and wire that into the repository. So that on method invocation, we effectively have a dispatcher in there that just sees, okay, this is a CRUD method. I need to delegate to simple JPA repository. This is a query method. I need to execute a query for that. This is a method that we've registered a custom implementation for. I'm going to invoke that stuff, right? So it's a delegation mechanism in general that comes in quite handy and allows you to easily pull together different functionality behind a single interface. The repository proxies are bootstrapped through some arbitrary factory. So there's a Java API for you to create those proxy instances that is not tied to a Spring container. It still needs Spring on the class path as a library, but it's not tied to the container, running. And on top of the factories, we have the factory beans, which are Spring container specific extensions, and there's also a CDI extension. So if you're working with Java EE, you can actually use the Spring Data repositories in that CDI environment as well. For the Spring side of things, we add the XML namespace and the enable JPA repositories annotation or enable Mongo repositories annotation, which, in case you're using Spring Boot, you don't actually explicitly need, right? Because we just detect that Spring Data JPA is on the class path and it's just going to work. Okay? So this is effectively what your repositories consist of. So we have the query interface, which combines CRUD methods, query methods, the QueryDSL functionality, and the custom implementation stuff. Right. So these 4 things. All right. On top of the repositories, we have quite a lot of stuff in the Spring Data project. We have, especially in the area of the pagination, we have integration with Spring MVC that will make sure you can easily extract page requests from a request parameter. And there's the Spring Data REST project, which will allow you to just take the code that you've just seen, turn that into a web project, activate Spring Data REST, and you will get REST resources exposed for each of the repositories of your application. Of course, with means to configure all of that, but it's the easiest way to expose repositories to the web, and that works for all of the stores that support the repository abstraction. So no matter if you're using JPA, Mongo, Neo, what have you, you can just quickly expose them. So you get that for free, effectively, with Spring Data REST. And yeah, again, I listed Spring Boot because that will just take the hassle out of setting up all of that stuff, and will take the burden from you to set up the infrastructure, JPA, and what have you. All right. So taking a step back from all this implementation specific stuff, the stuff you've seen so far is supported on for JPA, for MongoDB, and the Neo4j module and the Gemfire module. These are the pivotal supported, or the modules maintained by the Spring Data team, effectively. There is a very important module that's not even listed here, which is the Spring Data Commons module, which provides the foundation for all of that stuff. So things like the query method parsing and configuration support is all in Spring Data Commons, which caused a lot of developers from these that were using Spring Data JPA, for example, and having to work with a different store all of a sudden, thinking about whether it might make sense to take that abstraction and implement it for different stores. And that's where the community modules were actually born. And as you can see, we have a few of them for quite a variety of stores already. And these modules are are usually, they are driven by non-Spring Data team members, but it effectively means we're in close contact with these guys. We're making sure they are always up to date with our latest changes. They know the roadmap, and they will also eventually become part of the Spring Data release train. I mentioned that. I'll go into detail into that in a second. So that we actually they leverage our infrastructure, our continuous integration system, and we do some code reviews now and then. So just interact with our community and make sure it's easy for them to build stores. I've also got an email today from someone having built a DynamoDB implementation for that. So we will probably have to add one or two more modules to this list here. All right. To recap, the Spring Data Repository is an interface-based programming model. You see, especially in the context of the NoSQL stores, we're not trying to create a single unified API for all of these stores. We rather want to make sure that you can easily come from a Spring Data JPA project and get onto a project that uses Spring Data MongoDB, and you find yourself familiar with the way the repositories work. It doesn't mean that we can abstract all the implementation details of the store, but it should be easy to pick up other stores here. Yeah, start simple, as the code you've seen does, and get more sophisticated if needed. So make the simplest thing possible work in the first place. We have declarative query execution either through derived queries or manually declared ones. We have support for flexible predicate execution with Querydsl. There's also support if you need to stick with the criteria API. There's a bit of lipstick on it as well to make it more easy to define the predicates. You can, of course, plug your custom implementation code into the repo. And yeah, there's a CDI integration for those of you stuck with Java EE. And yeah, that's effectively it. If you want to know more about this, I recommend you to have a look at the Spring Data book we wrote with O'Reilly. It effectively also has a lot of sample code and takes a look at all the technologies listed here and evaluates and discusses in which situation these are used best and which requirements are best implemented with which store or which technology. If you need a quick reference card for you to have at the desk with all the keywords listed and the configuration overview and what have you, just Google for the DZone ref card on Spring Data. Yeah, it's just a free to download PDF, I think. All right, so what's upcoming? There's a webinar on Couchbase and Spring Data. I'm not quite sure. I don't think I actually listed the Couchbase module in the community modules, but there is a Couchbase module, and it's actually working quite decently already. Michael Nitchinger, the Couchbase Spring Data Couchbase lead, will take you through a tour on that module, I think in a week or so. We are also planning to have webinars on other Spring Data modules, like in end of Q1, early Q2. Yeah, so stay tuned for that. I'd like to encourage you to have a look at the upcoming Spring Data release train episode named COD. We're releasing individual modules in a release train to make sure that they all work with each other in terms of API changes and just making sure they're compatible with each other. So the COD release train, for example, will contain Spring Data JPA, MongoDB, Neo4j, Solr, and Spring Data REST. And the one after that will even contain more modules already. The reason why I mention this here is that we are in an RC phase already, and the GA release is planned for end of next week. So behind this link, you find a lot of information about what's new in the in this release, and feel free to give it a spin and report any glitches that you find, because I definitely would want to have them resolved for the GA release. All right. Okay. In case you'd like to have more information or have questions unanswered, feel free to reach out to either me or Thomas, or have a look at the project site, and or ask questions on Stack Overflow. We're monitoring the Spring Data tag and also the Spring Data JPA, Spring Data MongoDB tags, and answer where possible. That's it from my side. I think we could dive into some questions, if you don't mind, guys.
Yep. Yeah, we've got a lot teed up. Thomas has been doing great, answering a number of things in the background. One of the questions was, can one of the best practices that you describe include how to structure your packages when using two unique instances of the same repository? So in other words, two different SQL databases accessed through JPA, for instance.
I see. So that's a tricky one. I'd argue that I mean, you can just enable repositories on two different configuration classes, or use the XML element twice, and then point the XML element or the annotation to the other entity manager factory, right? So if you have two databases, you have two entity manager factories. What I definitely do is, what you have to do effectively then is qualify the repositories using @qualifier, and on the injection point, so on the client side where you use the repository, use the qualifier to disambiguate between the two instances of that single repository. What you also could do, what would lower the barrier here a bit, is just duplicate the interface. I mean, as you have to refer to one of the two anyway. Using a qualifier, you could just go ahead with the two interfaces, and maybe even extract all of the common functionality into a single interface, as we've done with the read-only repository. And yeah, what also comes in quite handy there is the ability to filter a repository, so you can by naming convention or what have you, exclude or include repositories from being picked up, and then just make sure you have a distinct configurations between the two. Yeah.
Thomas mentioned that the other deep dive repo that has some branches that have Java config examples without boot, as well as XML config, just for reference. I don't know if that makes a difference, but
yep.
Oh, sorry, go ahead. Okay.
Sorry.
Next question was from Thomas. From Thomas was, if a domain class is Java util map, how does the Spring Data Mongo project set the IDs on save? I don't think we support using map as a domain class, so you always have to have a wrapper around that, because exactly of the fact that you need an ID property. Yeah, that should be it, I think. I mean, at least I wouldn't really want to use a repository for a map. That's not really what a repository is for. So as repositories are defined to simulate a collection of entities, you're better off using a dedicated class as the top level, as the aggregate root that you export through the repository. So another Spring Data Mongo question: if you're using a Spring Data Mongo repo, is there a best practice regarding the use of a big integer versus a string for the ID type?
Between the two, it's hard to judge, and you probably have to. I mean, the only thing I can think of that can play the important role here is that which one is more performant within Mongo itself. both strings and big integers can be auto-generated, as the native object ID that MongoDB uses can be safely converted into strings and big integers. In case you're looking for auto ID generation, but I mean, I'm not too much into the to the deep performance details of MongoDB. So whether that makes it different, I think if we encounter a string or a big integer that's not populated, we will internally make sure MongoDB uses object ID anyway. So you have this conversion step, and then you get even into the micro performance differences between creating a big integer from a hex string value or a plain string value into object ID. But yeah, there shouldn't be too much difference, I think.
Excellent. Okay. Let's see. If Sri Bandari asks, current for pagination, Spring does issue a count method and then gets the page. Do you see underlying repositories implementing this in one call?
No. We of course have to issue a second query, right, to find out about the total. That might lead to a performance impact in the implementation. What we recommend to do instead is, you've seen that you can use the pageable alongside a query execution here. This method declaration will trigger the additional count query, because otherwise we cannot really come up with all the information in the page. If you just want to restrict the query result to a certain page, but don't need the meta information and thus want to avoid the second count query, just go with list here, right? We will detect that you're not interested in the metadata and omit the count query entirely. Yeah.
Okay. Let's see. Another couple more questions here. So, how would you force Spring to not try to convey an @ID to an object ID method for apps? It sets the ID using object to string, basically setting object ID as a string value. Sorry, that's kind of long, but it's in the chat if you're having any trouble.
Yeah, I'm not entirely sure I get the question or why you would want to do that, because internally MongoDB, I mean, if the question is if you can use other string values than a to-string representation of object ID, yes, you can. So if you just say I have my Mongo person object and I set the ID to foo, manually set the ID to foo, it will be persisted as is. It will not be converted into an object ID, because foo is not an object ID, right? But whenever you don't set the ID explicitly, we will create a string that is a valid object ID, just because of MongoDB actually recommending using object IDs. But on the other hand, you might want to avoid object ID to leak into your domain class, right? So that's the middle ground that we work on here. If that doesn't really answer the question, I think it's probably better to raise it on Stack Overflow or drop me an email, because the devil seems to be in the details there, and I'm not sure we get that really, or I really get that in that few seconds. But yeah, definitely would like to answer it if there's more detail to it.
Yep. Okay. Yeah. So Sri, if you're still on the line, which you appear to be, please feel free to follow up with him. Let's see. Another question. Is there a way to enable and disable lazy loading of an entity's associated entities and collections on a case-by-case basis using the @query annotation?
Not yet. The reason for that is that up until JPA 2.0, there was no unified way of executing or defining fetch groups in a provider agnostic way. JPA 2.1 added exactly that, so you can define fetch groups, and we're looking into support for those, so that you can either have the fetch group to be used annotated on the query, or even dynamically handed into the query execution. That's it. It's not there yet, but it's definitely on the roadmap. I mean, you could try to use the provider specific means, which usually means using query hints. So if you can define the fetch groups using the provider specific API or annotations, and then using query hints to trigger those, that should work out of the box. But for the new JPA 2.1 feature, we need dedicated support in Spring Data JPA.
Understood. Okay, cool. Thank you. Let's see. Still a couple more questions coming in, and we finished a little earlier this time, so I think we're doing well on time. What happens when the underlying data changes when using a page request? So, for example, let's say you start with 200 records, then you get back a page request, the first 10, but by the time you get back, only 5 records actually remain because the other 195 were, let's say, deleted. Does it keep the state on the records it was using for the page request and ensure that they're still there?
No, it doesn't do that. So
yeah,
what we do is
it too.
So I mean, we're not doing any real magic here, or trying to create a persistent view on the data at a certain point in time. It's really just about restricting the data to a window that is valid at the point of execution time. So if you query for the first 20 and you get even some of those are listed, and you're asking for the second page, and there simply is no second page after the first call anymore because of whatever reason, then you will simply get back no results there. You still get a page instance, but an empty one that's effectively restricted to or tells you that there are less elements than you requested and what have you. So we don't do any magic there, and we don't try to be overly clever, because that would just, okay, there would have to be some state management and what have you. And state is usually something you want to avoid in applications. But, so no surprise.
Oliver, while we're answering the last couple questions here, would you mind putting the GitHub repo up on the screen for people to see?
Of course. Cool.
Of course. Thank you. I think they've had plenty of time to get your contact info and all that. So
yeah, definitely.
Fantastic. Thank you. All right. So there were a couple folks that asked about this. So there it is, guys. He's got it flashed up on the screen. So while we're answering the next couple questions, that should give you time to write anything down you need to. Okay. We're almost done. Let's see. So Thomas answered with kind of this depends on your use case, and you may say the same thing, but I thought I'd just mention it. So Tobias also asked the same guy from the previous question, by the way, about the 200 records and some getting deleted. So he's saying, if you're using the business delegate design pattern, should the transactional boundary exist on the business delegate or in the service layer?
I'm not too deep into the individual business design patterns here, but just maybe a few words on the general approach to transaction handling here. As you've seen, we default transactions on the repositories, but we've designed the defaults to automatically take part in any transaction boundary that is already in place, right? So if you need to orchestrate calls between the individual repositories, you probably want to introduce a service layer that has an transactional annotation or whatever other means, and then you get multiple calls in a repository into a single transaction. How you actually design everything above that is totally up to you, and that totally, again, depends on, as Thomas said, on your use case. We've seen a lot of projects that skip the service layer these days. If all they need to do is CRUD in and out for a bit of data, so they have transactional controller methods or controllers and Spring MVC controllers or what have you. So that's definitely very depending on what you use. But how many layers you put in between is totally up to you. I'd recommend to start with as little as possible, of course, which can mean 0. But if you need to have dedicated control over that, like it's requiring a new transaction or what have you, that's totally up to you. There's no technical driver here that would force you into one or other decision.
Okay. He did clarify by saying, or maybe he was just continuing to ask the question, but he said if I had an iterator returned, it would still need to be in a transaction state when the objects get pulled out, right?
Exactly. I mean, as soon as you return from a repository, assuming you have no other transaction boundaries defined, as soon as you return data from the repository, in the JPA case, the entity manager gets closed as well, and thus the object gets detached, and all of the lazy loading stuff will not work anymore. For the test cases we've seen, I've just made the test cases transactional, so that there's a single transaction for every test method. And in web applications, what you usually see is the open entity manager and view pattern that will keep the entity manager open even if the transaction is not running anymore. But yeah, that's stuff you have to think about once you're getting into these details. Yeah.
Yep. Okay, I think we're down to our last two here. Mark asks, when you're using the @ID annotation with MongoDB in Spring Data repos, does Spring Data generate the ID that gets persisted to the database, or is it Mongo that generates it?
If you don't provide it yourself, it's actually Mongo that generates it, because we will just we turn that object into a basic into a DB object, into into the Mongo representation. We hand that to MongoDB, we get that back, and then we take a look at the ID that was generated and try to make sense of the. I mean, if you have a big integer in your as ID type in your domain type, then we take that object ID and transform that into the type of your ID of your domain class. So the generation is entirely Mongo. There's a bit of massaging going on in the Spring Data code if you're not using object ID directly. If you use object ID directly, you just get that back.
Excellent. Okay, I think we're at the last question here. Balaji asks, regarding that 200 record question from before, right, where we were talking about, deleting things and what state the database should reflect, right? So Balaji asks, if the data is read and the same result set is used to fetch the next set of records, then the original state of the database should be reflected even if the data is deleted from the underlying table. So I guess this is more of a comment, actually, excuse me, than a question. But,
no worries. It's probably good. It's probably good to clarify on that. We're not dealing with result sets in this regard. The thing is that we can't. There's no real way to find out when to there's no real session that we open up, which would allow us to stick to some result set and then reuse that for subsequent calls. I mean, in the usual case, it's just you ask for a page, you represent the page on a website or on an HTML page or what have you, and you send that to a client. And then along comes the next request, and there's no real way to combine these two, except you're adding some sort of state onto the execution, which is what you want to avoid, right? So stateful server applications don't really scale. I mean, and part of that is that if you're coming back to the result set, we're not really interacting with the API on that deep level. For Spring Data JPA, we simply use the JPA API to say set first result should be and set max result should be what have you. So it's just effectively telling the persistence provider to do the restriction, and whatever it does to transform that into JDBC is up to it. And when we get back the objects from the persistence provider, the result set and all of that on the JDBC level are already closed. It's very seldomly the case that you really open up a transaction and then iterate over the pages in a page-by-page basis, so that you could effectively reuse that information. That's at least not what we're doing right now. I don't even doubt that this would theoretically be possible, but it's not what we're doing right now. All right.
Okay. I think we're good. I think we've managed to scare off most of the webinar attendees, but at this point, there's only a few people left. So, and coincidentally, we are also at the end of the questions. So, all is well.
Awesome.
I just would like to invite you to join us on March 18th. If you're a Spring Security, if you have any interest in Spring Security, Matthias Arstesen will be talking about Spring LDAP 2.0 release on March 18th. If you're interested to learn, if you missed the Spring Framework 4.0 introductory webinar and you haven't seen the replay, Jürgen is going to be talking on March 25th about Spring Framework 4.0 support of Java 8. So we'll have some expanded Java 8 material, as well as a quick recap on sort of what's new in Spring Framework 4. But most of the session is going to be about our Java 8 support, and that should be coincident with the JDK 8, OpenJDK 8 release. So definitely something to check out. We will post this recording and replay on our YouTube channel within 2 weeks. Often we get it done a lot faster than that, mind you. And you can access that at spring.io/video, or you can just watch the blog posting on spring.io/blog. If you'd like to be notified about the replay, just subscribe to the YouTube channel, or better yet, subscribe to the Atom feed on spring.io/blog, because then you'll get notified about other upcoming webinars, as well as get all the great blog content and Spring 1 replays and stuff like that from our engineering team. So with that, I think we're going to wrap it up. Oliver, Thomas, any final comments before we sign off?
Nope. Well, thank you very much for attending. Thank you to Thomas for answering all the questions. And yeah, that's it.
Yeah. Thank you. Welcome.
Fantastic. And I should mention that the link to the slides will be in the YouTube video description as well if you're looking for the actual slides. So with that, just want to say thanks, everybody, and have a great day. Appreciate your time, attention, and all the interactivity. It's really great. See you at an event again soon. Take care. Bye.
Bye.
Bye.